Hello students, welcome back. Let us resume our discussion in section 2. Previously we talked about the standard form and the factorization, not factorization method, excuse me, went through quadratic formula method. We went through these two example problems, and also we discussed the relationship between the square root method and quadratic formula method. We went through all those. Basically, we covered everything except the factorization method. Well, basically, what I did in previous video was to clear the way for something important. Okay, factorization method. The first method revolves around problems like these. These kind of quadratic equations are called monic. Monic comes from mono. Mono means one. And look at this kind of problem. The leading coefficient is 1. Again, look at this. Leading coefficient is 1. And it's a bit harder for these, but after some simplification, you're going to get a monic quadratic equation. Let's postpone these two, at least for the time being. And then later, we are going to consider non-monic quadratic equations like this. Leading coefficient is 3, not 1. Next one here, the leading coefficient is 10 for the second problem. And now this one, I cannot tell at this moment. After simplification, it'll become clear. In any case, let's postpone that. Okay, that's the order, that's the strategy. Let's begin with the simplest monic. So the simplest monic quadratic equation, and let's work it out. How do you factor a monic quadratic trinomial? Don't worry about the leading coefficient. 1 is monic, so 1 times 1 is 1, nothing to worry about. Everything revolves around the constant term generating the linear term, linear coefficient. Factor of positive 8 adding up to negative 6. Let's put some space in between. The factors of positive 8 adding up to negative 6. That's all I want. X minus 2, x minus 4. So negative 2 times negative 4 is positive 8, and they add up to negative 6. Is there any other pair? No, the pair is always unique. If they exist, then always they are unique. Well, x minus 4 times x minus 2, okay, we can change the order, but in terms of solution, no change, because setting up x minus 2 is equal to 0, I'm going to get what? X minus 2 is equal to 0, therefore x is equal to 2. And that's coming from the first factor, which I just highlighted in blue. From the second factor, I can set this one up to 0. X minus 4 is equal to 0, therefore x is equal to 4. And that's the second solution coming from the second factor. Are there any more? No more. Blue times red is equal to 0, and one of them has to be 0. Either blue is 0, in which case I have x is 2. If red is 0, I get x is 4. There's no way I'm going to get 0 by multiplying two non-zero numbers, so one of them has to be 0. Blue is 0, we get x is 2. Red is 0, we get x is 4. That's how you do those kind of problems here. Let's do another problem. Another simple monic problem. Oh, I didn't want to show you the answer key right away. Please pretend you didn't see it, okay? This time, factors of negative 18 adding up to negative 7. Let's put some space in between. You see, sine is part of the next number. The factors of negative 18 adding up to negative 7. Previously, factors of positive 8, so we have to have two numbers of same sign. Negative 4 times negative 2, so that we get positive 8. This time, we need two opposite signs. So two opposite signs, and then add up to negative 7, so a bigger number part will be negative. So what do you have? Do you see y minus 9, y plus 2 equal to 0? Do you see that? 9 times 2 is 18. Negative 9 times positive 2 is negative 18. And if I add up negative 9 plus 2, that's negative 7. Looks good. It's working. And we can do the same. Set this one blue and set this one red. And from the blue factor, y minus 9 is 0, so y is 9. That's what I get from blue factor. And then y plus 2 is 0, so y is negative 2. That's what I get from the red factor. Any more solution? No way. Blue times red is 0, which means one of them has to be 0. There's no way I'm going to get 0 by multiplying two non-zero numbers. One of them has to be 0. So we get 9 or negative 2, as you can see from this answer key here. By the way, always we have the sign change. X minus 4, so x is positive 4. X minus 2, so x is positive 2. Y plus 2, so y is negative 2, like that. The reason we have sign changes is because if you set up and flip this positive 2 to the other side, we get negative 2. Flip this negative 2 to the other side, we get positive 2. So that's where we have the sign change. Let's see, do we have enough time for some more complicated problem like this? Let's try. How about a problem like this? Okay, at this moment it is unclear whether this is monic or non-monic. I mean, there's z squared here. And for the right hand side, looks like I'm not getting anything squared, so z squared plus 2z minus 18, and then break up the parentheses, 6c minus 18. Did I break up correctly? This should be this 2, positive power, positive sign, so breaking up is easy. Now subtracting negative 18 from both sides, so these will just cancel each other out. Z squared plus 2z minus 6c is equal to 0. Am I doing it right? Z squared and then minus 4z equal to 0. Everything correct? So z minus 4 equal to 0. So from the first factor we get z equal to 0, and from the second factor z is 4. How's that? This one, which I'm highlighting in purple, versus this one, which I'm highlighting in green. Purple, z is 0, that's straightforward. Factor z is z, so that equal to 0. And for this one, z minus 4 is 0, so flip over, we have sign change. So we have these two solutions, 0 or 4. Yeah, I have answer key here, everything fits. And what did I do basically? I just did this. Denominators number 1, parentheses number 2, like terms number 3. Even for quadratic equations that has to be manipulated into standard form, x squared plus bx plus c equal to 0 form, still you have to simplify in a way that you remove the denominators first, but here no denominators. So next, break up parentheses, and then from there take the like terms and simplify all the way to the standard form. And then you can do the factorization and then get the problem done. Here's another example. I hope I have enough time, just enough time for this. Okay, alright. How do I break it up? 3t squared plus 3 equals 2, and then break up negative 2 times 3, negative 6t, and then negative 2 times 1, so negative 2. Did I break up correctly? Next, let's apply the like terms. Quadratic term done, and then linear term 6t, and then the number, this 2 minus 2 go out, so I have only plus 3. Okay, some simplification is in order. T squared plus t plus 1 equal to 0. Oh, I forgot 2 here. 6 divided by 3 is 2. How do I factor this? Well, factor of the constant term, we have 1 times 1 only, so t plus 1 equal to 0. In other words, this is t plus 1 squared is equal to 0. And then we end up with just one factor. T plus 1 is equal to 0, or t is negative 1. So what do you get? We have a double root. So this thing squared is equal to 0. And setting the inside equal to 0, we get a double root. Or you can look at it like this. Setting this green is equal to 0, or oh, this 2 is same as green, so we end up with only one solution. That's another way to look at. In any case, we went through a bunch of example problems of Monic quadratic equations. If you need some simplification, such as breaking up parentheses, go ahead and do that. In the end, take the like terms and then simplify further into the standard form, ax squared plus bx plus c form, and then you go ahead and do the factorization. When you factor, just use technique for Monic quadratic trinomial, and that's easy to factor. Just look at the constant term, factors of constant terms adding up to the linear coefficient. If the constant term is positive, we need positive times positive or negative times negative, depending upon sign of the linear coefficient. If you have negative constant term, then you need two opposite signs. Remember those kind of things? Okay, so much for Monic quadratic equations. Next time, let's consider non-Monic quadratic equations.